Hi, welcome to the 2D Tips Lightning Round. I'm Scammell, Product Manager for 2D.
And I'm Eduardo, Product Marketing Manager for 2D at Unity.
Let's start by considering what you should do when beginning a new 2D project. When starting a new project from Unity Hub, you can use the improved 2D template to get started quickly. The 2D template has been set up with settings that make sense for 2D projects. The default scene uses a 2D view and comes with a camera set to orthographic projection and clears to a solid color. The editor is set to 2D mode, which means that new textures are imported as sprites. Also, all real-time global illumination has been turned off by default. The 2D template pre-installs all the 2D packages. This includes 2D animation, 2D pixel perfect, 2D PSD importer, and 2D sprite shape, as well as all the necessary dependencies. In Unity 2020.2, we've streamlined our 2D menu items so they are now displayed in neat top-level menus for object and asset creation. These include a set of primitive 2D sprites that have been set up for quick prototyping. We've also added menus for some of the features added more recently, like Sprite Shape and the Pixel Perfect camera. Pixels per unit is a central concept in 2D. A sprite's pixels per unit value, or PPU, determines how many pixels of width or height in a sprite image correspond to one distance unit in world space. It's important to consider the PPU of your sprites as early as possible. Apart from controlling pixel density, it also affects how sprites are used by the sprite renderer draw modes, as well as other systems, like the Tilemap. You can use the 2D PSD importer to import Adobe Photoshop PSB files into Unity. When you import PSB files with this importer, you can use features such as Mosaic to automatically generate a sprite sheet from the imported layers, and Character Rig, where Unity reassembles the sprites of a character as they were arranged in their source files. This is designed to work well with 2D animation and multi-layered character workflows.
There are many techniques for building 2D levels in Unity. Let's explore some of them together. Today's devices have millions of pixels. It is advised to reduce the number of passes required to draw the final color to the screen. When pixels are semi-transparent, each overlapping pixel must be considered when calculating the final color. Overdraw of overlapping transparent pixels is bad for the performance of the GPU, especially on less powerful devices or when higher frame rates are required. All the sprites in your scene will be considered transparent, but there's ways to reduce the overdraw. Unity will only overdraw the pixels inside your sprite mesh. With full rect, the complete area will overdraw. But if you use the mesh type tight, the area to overdraw will be smaller, since the generated mesh will only follow the outline of your sprite, ignoring the empty areas. If you want to have more control over the outline of the mesh, you can change it from the sprite editor. Another optimization trick to reduce overdraw is to merge overlapping static sprites. If the sprites don't have to move, or you don't need them for a parallax effect, consider merging them once your level design is finalized. When you have many sprites with static 2D colliders, consider combining those colliders with the composite collider 2D component. It will not only be more performant, but will also provide a smoother collision with the entire surface. It can be used with tile maps. For example, the purple tiles on the screen are used as colliders. We enable it by adding the component and checking the box used by composite. The composite collider 2D can also be used with parent game objects. Make sure the child colliders have the checkbox enabled. Another option to optimize colliders can be to manually draw a simple polygon that works well with your game object. The tilemap renderer is a performant and convenient way to design your game. Every renderer attached to a game object, like a sprite, has some overhead. If you want to display many static sprites efficiently, make use of tilemaps when it's possible. With just one renderer, the tilemap can render hundreds of sprites. When sorting is not needed, but you have many sprites to render, consider using Tilemap chunk mode. If you need those sprites to be sorted correctly, for example, if they have the character moving in front and behind the individual tiles, use individual mode. For sprites that need to be moved or have gameplay functionality, use regular sprites. In our test, we can observe that using Tilemap chunk mode, when possible, will reduce the use of the CPU and take less memory. This is particularly helpful if you are targeting low-end devices. To use Tilemap's chunk mode, put all the static tiles that can be batched in the same tilemap and enable chunk mode. Also, make sure that all the tiles are in the same Sprite Atlas. You will notice how the tiles might not be displayed correctly in the scene view, but they will be sorted correctly when you enter play mode. Maybe you can design your level using individual mode and change to chunk mode when you are ready to publish. Sprite Shape is the 2D tool to design organic shapes and levels. By default, the Sprite Shape API allows you to change the nodes of the spline at runtime, which can impact performance. This is great if you plan to make use of it, but if you don't, you can bake or cache the geometry of the spline. In this small demo, it can take us up to 1% of the frame rendering time, even though we are not modifying the spline at runtime. If you don't plan to make use of the functionality, select Sprite Shape Controller, Edit Spline, Enable Cache Geometry. We can see now that with the same demo, the function BakeMesh doesn't take more than 0.1% of the rendering time. In newer Sprite Shape versions, modifying the spline at runtime will receive a big performance improvement by installing the Burst package. Sprite Shape profiles can look similar to vector drawing software using different brushes. You can in fact design your environments with it in a similar way, not only for gameplay elements but also decorative elements. It comes particularly handy to fill large areas and it works well for different art styles. It also uses very few assets. In the previous sample, you can see how simple the original assets are and how quickly they can populate a game without feeling repetitive. Make use of these features to create rich worlds in an easy way, minimizing the amount of sprites required. The draw modes of the sprite renderer can help you save asset size and make the process of designing levels more fun. With tileable sprites, you can have different game objects using the same sprite in different sizes without stretching the sprite. Go to the sprite editor and move the yellow handles to frame the part of the sprite that should be tileable. Apply it and then go to Game Object and change the sprite renderer draw mode to tile mode. From there, we can change the height of our street lamp. Additionally, you can change the pivot point to the base to keep the object in the right location while we change the size. Similarly, with 9 slices, you can design your level using blocks that can scale and be arranged as you want while they look sharp and in proportion. In Sprite Editor, select the area that should be tileable and make sure that the corners fit in the corner area that won't be repeatable, and select Draw Mode to slice. When you are designing 2D games, there will be situations where some of your game objects will be in the same sorting layer and also in the same order. You could create many layers and some logic behind your moving sprites to sort them in the right order, but this wouldn't be very efficient. As you can see, the draw order of the sprites doesn't seem right. The way we tell Unity the right order to render sprites in those situations is with the transparency sort mode. First, let's check the project settings, transparency sort mode. Let's choose custom axis. In our 2D project, we want the characters to move to the front as they move to the bottom of the camera. Let's change the transparency sort axis to Y1. Now it seems to be working, but the characters are changing planes when they cross each other's center points. The reason for this is that we are indicating to Unity that our sprites should be sorted based on the center. Let's change it to pivot point. The pivot appears already at the bottom like we want, but we could choose any other location from the sprite editor. Now it works as expected. And if we rotate or scale the sprite, it will do it from the pivot point, which can also be helpful. For other games, we might not want the sprites at the bottom to be in front of the camera. In a cars game, we will want the car on top to be more visible, and maybe we also want to give priority to the cars on the left side. You can see how the default sorting axis is not rendering all the piles of cars as we want. Transparency sort axis is a simple vector 3. It represents a direction that Unity uses to do the sorting. That's why, in this case, we will modify two custom axes to create a diagonal vector to sort the cars from bottom right to top left. Once we apply the changes, we can see how all the piles of cars are rendered in the order that we want.
Now we're going to breathe life into our 2D games with 2D animation. Creating a frame-by-frame animation clip in Unity is simple. Select a sequence of sprites in the project view and drag them into the scene view or the hierarchy. An animation clip and an animator will be made for you automatically. If you want to add to the animation clips on an existing animator, simply drag those animation frames onto the animator's game object. The clip will be added to the animator. Alt or Option drag if you want to create a different game object for each sprite. Unity supports both frame-by-frame as well as bone-based animation. But how can you decide which system works best for your project? Let's consider the differences. For bone-based animation, each frame of animation uses the same sprites, and each animation clip uses the same sprites as well. It works well for variable animation speed. The Unity animation system can be used to create smooth transitions between clips, and it works with 2D inverse kinematics for more intuitive posing. For frame-by-frame animation, each frame uses a unique sprite, and additional animation clips will require additional sprites as well. The frame rate and speed is usually constant, and transitional animations require additional transitional sprites. And finally, it doesn't work with the 2D inverse kinematic system. By installing collections and burst packages, 2D animation can optimize performance for high bone counts and sprite meshes with high vertex counts. Animated sprite deformation at runtime will also get a performance boost. This works by allowing the 2D animation package to use burst compilation and low-level array utilities to speed up Unity's processing of the sprite mesh deformation. Try it out yourself. Make sure you are using Unity 2020.2 as well as 2D Animation 5.0.1. Install the burst and collections packages by editing the manifest.json file in your project and add the following lines to the dependencies section. When preparing a sprite for rigging, you have complete control over the mesh. To get started quickly, the skinning editor provides an automatic tessellation option. However, you can customize this by using the mesh tools to add and remove vertices to craft the mesh that you need. You can add 2D colliders and 2D rigid bodies to bone-based characters to drive the motion via the 2D physics system. In this example, we have added capsule colliders to each bone, as well as rigid body 2D components. Next, we connected them with hinge joints. You can use angle limits on each joint to limit the range of motion, and you can also toggle whether the rigid bodies connected via a joint should collide with each other. Putting all of this together gives us a rudimentary ragdoll.
In this section, we will look at tips to keep your pixel art beautiful and sharp. A key aspect for good pixel art is to be consistent in the pixel density across all our assets. If our project has 32 pixels per unit, we can expect one unit to contain 32 pixels, like our tile on the left side. As a reminder, the default camera has the size expressed in vertical units from the center of the camera. That means that in our setup, we could fit 10 tiles vertically. For the chest, we want it to be smaller than a tile, so we chose a size of 24 by 24 pixels. When we add it to our Unity project, we can see how it appears a lot smaller than we thought. This is because Unity's default pixels per unit is set to 100. When we change the sprite asset configuration to our project 32 PPU, it changes to the right size. By default, bilinear filtering is enabled for assets to smooth the hard edges. but we want the opposite effect, so we change the filter mode to point. Our assets now look sharp and taking the screen space that we defined at the beginning. When you have many assets to import to your project, changing the setting for each individual sprite to match your project settings will be very time-consuming. You can instead create an importing template or preset. That way, every imported asset will have the predefined configuration that you want. You need to select an asset with the configuration that you want. Click on the settings icon next to the sprite asset to create a template from this asset. Save it with a name that helps you remember what it does, and you will see the preset asset in your project. Now you can make it default, so all new imported assets will have that configuration. If you are working with pixel art, you probably want to make sure that the screen always shows the same number of pixels and all those pixels stay always the same size. First, go to your camera and add Pixel Perfect Camera. Set the asset pixel per unit to the one that you use in your pixel art, in our case 32. Once you add the component Pixel Perfect Camera, it will take control of the camera on plane mode, but you can also see the changes in the editor if you activate Run in Edit mode. You can see that only the Pixel Perfect Camera, the one with the yellow gizmos, is the one changing what appears in the game view. In your project, characters or objects will be in motion. They can change their position, rotation, or change the size. By default, they will have a smooth interpolation, but if you want to stay true to the pixel art limitations indicated by the pixels per unit of your project, enable Upscale Texture. The game objects will move in increments of 1 pixel. The rotation and scale changes will also respect the visual constraints. If you want to learn more about tips to create retro-looking games, you can check 2 blog posts that we made on how Pixel Perfect Camera can help you achieve through 8-bit and 16-bit aesthetics.
And finally, let's consider some ways to improve 2D performance while staying productive in the Unity editor. Sorting groups allow you to group 2D renderers together. In this example, we have 2 characters without sorting groups. We are relying on sorting layers and order in layer to make sure the rendering order is correct for each character. As you can see, this fails when they overlap. The individual parts become interlaced. You can place a sorting group on the root game object for each character to group the renderers and sort them as one. With the sorting groups, the characters no longer interlace and sort as a group. Sorting groups work with all 2D renderers as well as particle systems. A Sprite Atlas is an asset that packs several sprites into a single combined texture. Unity can then use this single texture to increase performance by issuing a single draw call instead of multiple draw calls for each sprite. In this example, we have an environment with a background and multiple props. As we can see in the frame debugger, each sprite is drawn on a separate draw call. All these sprites are located in a single folder. We will take advantage of Sprite Atlas's support for packing folders. By adding a folder to a Sprite Atlas, you can freely add and remove sprites from your Sprite Atlas over the course of your production by simply changing the contents of the packed folders. As we can see, all the sprites in the scene are now being rendered in a single draw call. It is also possible to create variants of Sprite Atlases that are at different sizes or have different compression settings to target a range of platforms with the same source assets. Let's look at an example that uses axis distance sort, sorting groups, and Sprite Atlases together to get a scene that is easy to work with and efficient to render. In this project, we are using axis distance sort to sort sprites along the y-axis. Each character has a sorting group at the root level, and even though we could pack everything into a single Sprite Atlas, we have chosen to split them up into a desert environment and core character atlases. This is because the core characters are available in every level of the game, but the environments change with each level, and we don't want to carry the overhead of all the other environments or non-core characters. You should consider an atlasing strategy that works for your game. Sprite Atlas has been designed for exactly this kind of flexibility. We now have a scene that balances productivity, flexibility, and performance. For more information on the 2D tools, check out the links in this session's description. Thank you for watching, and keep making amazing 2D experiences in Unity.